Hello everyone, welcome to my YouTube channel CNC for TDM. Today we are going to discuss in this video surface roughness. You may also call it surface finish. So it is very important, surface finish or surface roughness. So if a surface is smooth, the life of the component is increased, and moreover, if it is a rough surface, so roughing operations are there, like turning, milling, these machining operations. So if you go for finishing operations, just like grinding and then polishing, buffing, then surface finish increases, cost also increases. So it's very important, surface finish. So let us discuss surface finish. If you see here, this is a part component and this is a machined part. If you see in the top surface, if you see this, this is waviness, like this. One error is waviness. One error of the surface is waviness, machining error. Other is surface roughness. So if I have taken this, I have zoomed this area. If you see here, this area, this is roughness height here, and this is the roughness width. So this way we are creating surface in machining. So this type of surface is there. If you enlarge this on the microscope, you will see the shape like this only. So let us discuss here. If you see, this is basically, this is a surface, and this AF is actual profile. This is the actual profile of the surface, like this. These are this peak and valleys are there. This is peak, this is valley. So this type of surface we create by machining. Okay, then we take this as a mean line. MF is the mean profile. MF, this is the mean line. Say this is a mean line, and from the mean line we take mean line just like upper area of the upper this and these valleys. These are valleys and these are peaks. So if we add all these areas, this should be equal to the bottom areas. This area A1, A2, A3, A4. If you add these areas and the top areas, this should be equal. Then we can draw a mean line like this here. So this is our mean line, MF. So if we draw here vertical lines like this, H1, H2, H3, H4, like this, we draw these lines. And if you see here in this, so there are 2-3 type of measurement we do in the surface measurement with the help of measuring instrument. If you see, this is RT. RT means total roughness. If you see, this is your reference profile, top profile here, and this is datum profile, DF, datum profile. From datum profile to top profile, this total height. So this is equal to RT, means total roughness. In the same way, if this is your L is total sampling length. This is our sampling length. Sampling length may be 2-3 mm or whatever as per the requirement. So this is sampling length. In this length, if we measure this is our total, RT is total roughness. And so this is height H1, H2, H3, like this. So this line, this lower line, this height is RA value. RA means average roughness. This average roughness, and this top line, this line, this is RMS value. RMS is root mean square value. So this value is in microns basically. It may be 2-3 microns, 4 micron, 5 micron. How much is your surface? It is finish or rough. It depends upon that. So this value, RMS value or RA value. So how to check this RA value and RMS value, that we are going to discuss now. So if you see in this figure, this is our mean line. This is mean line here. If you see, this is mean line, and these are the areas up from the mean line. These upper areas and lower areas. If you see this, the RA value. What is RA value? RA value is A1 plus A2 plus AN divided by L, sigma A upon L. If you add all these areas, say this is our area, this is area 1, this is area 2, this is area 3, and this is 4. If you add all these areas and divide by L, total length, so this will be RA value. So one more formula is there. These are H1, H2, H3 and Hn divided by N. N means total number of lines. So that way also you can calculate RA value. So this is RA value, average roughness. And in the same figure, RMS value is also there. RMS, root mean square. How we calculate root mean square? What is the formula? This is H1 square plus H2 square plus Hn square divided by N. This H2 square, H3 square, Hn square under root and divided by N. So this way we can calculate this RMS value. So these are all heights, H1, H2, H3, H4. And if we take squares of this, H1 square, H2 square, if add all these squares, and then we get this under root of this square root, and then divided by N. N means total number of lines. How much are the total number of lines? So this way we can get RMS value. So this RMS value and this is RA value here. And third is RZ. How we calculate RZ? This is a line. From this line, these are the peaks and valleys like this. So we draw just a line and we take the heights like this, H1, H2, H3. So we take total 10 heights, 5 peaks and 5 valleys like this. This is H1, this is peak, H2 is valley, then again peak, then valley. So we take 10 points, and H1 plus H3 plus H5 plus H7 plus H9. All the peaks we add here minus all the values H2 plus H4, H6, H8 and H10. If you minus and then divide by 5. So this will be the value of the RZ into 1000 divided by vertical magnification. So it will come in microns. So this way we can calculate the value of RZ also. So these are RZ, RT, RMS and RA. So these values we can calculate like this. Okay. So now if you see here, this is evaluation length, total length, and this is sampling length. One is this sampling length. There are 5 sampling lengths. 1, 2, 3, 4, 5. 5 lengths are there. And this is sampling length. So this value given is here RZ. So how it is calculated RZ? So in all the 5 samples we have taken RZ1. This value we have taken RZ1, Z1. So from that formula, 5 peaks and 5 valleys, we take this RZ1, RZ2, Z3, Z4 and Z5, and we take average of all these. It will become RZ. So this way we calculate RZ, and this is RT, total roughness. So this is peak value, total peak, and this deep valley, this valley and this peak. So this total distance from the peak valley and this peak valley and this top point like this. So this is RT, means total roughness. So this is our total roughness. So this way, and this is evaluation length. We take this, there are 5 sampling lengths, and then we calculate RZ like this. So, and this is total roughness. So this way we can calculate this also. And so these are the values we have already discussed. RMS value, RA value, RZ value also, how to calculate this RZ value. So this way we can calculate these values in microns, how much is the roughness height. So if you compare this RT total roughness, it is approximately RT. So if you see here, RA value is this much height from mean line to this is RA value, and RMS value, it is approximately 10% higher than the RA value, approximately 10%. And then this RT is approximately 8 to 10 times from the RA value. We will discuss this in the chart, comparison chart also. So this value is 8 to 10 times, and this RZ is approximately 6 to 7 times. So this way we calculate these roughness values. Okay, if you see here, this indication of surface roughness, how we indicate in the drawing. In the drawing, if you see, if this is the symbol, and it means that this may be any production process. If it is open from the top, and you just give the value here. You give the value, how much is the roughness. And if it is a machined surface, then this triangle is closed like this. Triangle is closed, and this value is written here. And if the surface is obtained without any machining, there is no removal of material, just like casting and other things, forging, verging. So that way we just put a circle here. So that means machining is not required here. Machining, removal of the material is not required. So this value of the surface finish is given here, or surface roughness, this value is given here. And if you see this symbol here, what is there? A1 and A2. These are the two limits, maximum limit and minimum limit. Limits of the surface finish, limits of the surface roughness. This value we can give here like this. And if you see here in this figure, so this A is the roughness value RA in micrometers, means in microns you give this A value. How much is the A value? You just give this value. And what is here then, or you can also write roughness grade number 1 to 12, N1, N2, N3, roughness grade you can also write here. What is the roughness grade or roughness value? Okay. Then D, what is D? D is direction of lay. Direction of lay means it is whether it is perpendicular to the this surface or it is parallel. So that is called lay. Lay means, say this is a surface and machining process is like this. These are the grains of the machining, like this, like this, like this. So if you are checking along this lay or perpendicular to the lay, this pattern, machining pattern, if it is perpendicular to the pattern, then we write a D here like this. This is perpendicular. Okay, if it is parallel, then we give this parallel like this, 2 lines, it may be parallel. Okay, then B, if you given, it is given here B value. What is B? B is production method for treatment or coating. So what is the production method, whether it is milling, turning, whatever is the machining process, that you can write here. B. Okay. Then what is C? C is sampling length. How much is the sampling length? We provide here sampling length. And F is roughness value. In bracket, sampling length and roughness value, both we provide here like this. And here E is machining allowance. If there is any machining allowance, 0.1 mm, 0.2 mm, whatever it is there, and then you provide this here also. So this way you define on the drawing. If you find this type of symbol, now you can recognize how much is the roughness value, what is the D value, what is B value, what is this, so that you can recognize very easily. Okay, now let us discuss this comparison table. So, if you see here, this is given RA value. In the comparison table, RA value, it is in micro inches, it is in microns. Okay, so if you see here, this is RMS value, root mean square value, root mean square. This is CLA value, CLA RA is same. RT is total roughness. N is roughness grade. It is 1 to 12, 1, 2, 3, 4 like this. And this is cutoff length. Cutoff length means sampling length. How much is the sampling length? So it all depends upon the surface roughness value. How much should be the sampling length? Here if you see, this in mm, sampling length, if you go for, just take one example of 1.6 micron. We take this example, 1.6 micron. So 1.6 micron we can achieve by grinding also, by milling also, 1.6 micron. So in micro inches it becomes this value 63. Okay, and this is RMS value, root mean square value. It is approximately 2-3% more than RA value, 63, it is 64 like this. CLA value 63, it is same as RA like this. And this is RT is the total. Total is given 8.0. Here this 8.0 is in microns. This was in micro inches. These values 63, 64, 63, these are in micro inches. Whereas this is in microns, RT, 8 micron, and here it is 1.6 micron. So it is approximately 5 times more this value, RT total. And this grade is N7. We can write there N7 like this. And cutoff length, if you see here in mm, it is 0.8 mm. So in the length of 0.8 mm, with that instrument, generally we use telesurf is one instrument. With the help of telesurf, we can measure this surface finish, and we take this sampling length 0.8 mm and surface finish is 1.6 micron. So similarly, if surface is very rough, say it is 50 micron, if surface finish is 50 micron, then we take it 8 mm sampling length. So sampling length also increases. It is directly proportional to the RA value like this. So this way we can compare it. How much is the RT total roughness? How much is the total roughness? If you see here 0.3 mm. If you see in the first row, it is 0.025 and it is 0.3, approximately 10 times like this. 0.05 and it is 0.5. It is 10 times almost. So this way you can see here the total roughness is from peak to valley, total distance, and RA value we have already seen how much is it is measured from the mean line, the RA value. So this way, and this CLA value, it is approximately it is same as RA, and this RMS value is something 10% more than the RA value, RMS value. Okay. So, okay. Thank you for watching. If you have any problem, you may discuss in comment. Thanks. See you in next video.